All right, what we are doing today is called implicit differentiation. So we're still taking the derivative, but it's going to open up the door for us to take the derivative of different types of equations. So let me get a couple of vocabulary words in here first. The equation y equals 3x squared minus 7x plus 5. It's expressed in what's called explicit form because the variable y is explicitly written as a function of x. Probably more in layman's terms, we've solved that equation for y, or somebody has solved that equation for y. We didn't do it. But this next equation right here is called an implicit equation, and it would be very difficult or even impossible in some situations, maybe in this one, to rewrite it in a form where we have just y equals and then just x's. So we still need to be able to take the equation or the derivative of a function that I can't solve for y for, and that's where implicit differentiation takes place. Basically, when finding dy dx implicitly, you must realize that the differentiation is taking place with respect to x. So when you differentiate in terms involving x, you can differentiate as usual. But when you differentiate terms involving y, you must apply the chain rule, which means, like right here, if I was taking the derivative of negative y squared, it would be negative 2y times dy dx, because I need to take the derivative of that y. Let me work a couple of examples, and I think you'll catch on pretty quickly. Well, you would use it in physics, definitely. For any equation that you can't solve for y, you would use this. The thing is that your world has pretty much been centered around functions in this so far in math, where it passes the vertical line test. But there are a lot of situations or other equations that are not functions. And in that case, you can't solve the equation for y, and we still want to be able to take the derivative because derivative represents rate of change. And it's all about the slope or the rate of change. All right, so on number 1, the derivative of y cubed is 3y squared times the derivative of y, which the derivative of y is written as dy dx. And then what's the derivative of x cubed? 3x squared, right. And technically, the derivative of x is dx dx. It's the derivative of x with respect to x. So what is that really? 1, right. So it cancels, and that's why we don't ever write that. And then the next term, the derivative will be 2y dy dx, because I'm using, y'all understand how we're using the chain rule here, is that we're using the power rule, but then I have to take the derivative of what's being raised to that power. So dy dx, and then what would the next term be? Good. Minus 5 dy dx minus 2x equals what? 0. Good. The derivative of a constant is 0. Tamar? Not really, but let me think about that. But we're not finished yet, so that may kind of answer your question. We want to find dy dx, so ultimately I need to solve for dy dx. So the way I'm going to solve for dy dx is I'm going to take every single term that has a dy dx in it, and I'm going to leave it on the left side. And any term that does not have a dy dx in it, I'm going to move to the right side. So 3y squared dy dx minus 2y dy dx minus 5 dy dx equals 2x minus 3x squared. Y prime, maybe? Instead of dy dx, you could call it y prime. All right, now if I wanted to solve for dy dx, any suggestions? Factor it out. Good. So everything on that left side now has a dy dx in it, so I have a common factor of dy dx, or y prime. The derivative of x is dx over dx, because we're taking the derivative of x with respect to x. Right. So dy dx is the derivative of y with respect to x. What it means is it's the derivative of the dependent variable with respect to the independent variable. Kelly? Mm-hmm.
Why isn't the dy dx just y? If it's just because it's not in relation to x.
It's right. It's because it's a y instead of an x.
So you can't just use the thing at all.
Right. All right. So then the last step would be to divide by this bracket right here. So we would have 2x minus 3x squared all over 3y squared minus 2y minus 5. And you're done. Yes, it's okay to have it in terms of y, but now, and it's okay for y's to be in your final answer, but now the way that this final answer is written is that what this means is the slope of this graph at any point is this big mess right here. So in order to find the slope at a specific point, I need to know the x value, but I also need to know the y value, right? It just means that the slope is now in terms of both x's and y's. Yeah, like now we could find the slope of a point on a circle, because a circle is not a function. And a circle you can usually solve for y, but some other weird functions you literally can't solve for y. One thing I want to point out about the back of your book is depending upon, up here in this second line, depending upon whether I had my dy dx's on the left or on the right, is going to kind of depend upon the signs of your final answer. If every sign is completely opposite in your final answer, like if you had negative 2x plus 3x squared over negative 3y squared plus 2y plus 5, that's the exact same thing. So if for some reason every single term on your paper is completely opposite of the answer in the back of the book or the solutions manual, you do have the right answer. Yes, Brian? No. We're not about to learn a shortcut. I'm sorry. No, there's not a shortcut. No. You have to do it this way. Gray? Okay, when we talk about an equation, or when it says find dy dx, that means find the derivative of the equation whose dependent variable is y and whose independent variable is x. And so you always take the derivative of each variable with respect to the independent variable. Well, like, if you just have y equals 5x squared plus 7x minus 3, then if I ask you to take the derivative, you're probably going to write y prime, which y prime is really the same thing as dy dx, and that's just saying I'm taking the derivative of y and with respect to this independent variable x over here, basically in terms of x. And then 10x, but when I take the derivative of 5x squared, technically it's 10x, but it's dx dx. I'm taking the derivative of x with respect to x, so it cancels. You don't put the dx dx. And then technically plus 7 dx dx, but that's really a 1. So the bottom line is anytime you take the derivative of something other than y, you have, or sorry, anytime you take the derivative of something other than x, you have to write dy dx. So last.
So what we're doing is we can't just write y prime?
If you would rather write y prime, I'm okay with that. However, we're going to start taking section 2.6, our application problems, and a lot of those application problems deal with time. And so I'd rather you write dy dx, because it's not always going to be y's and x's. Sometimes it's going to be y's and t's. Sometimes it's going to be x's and t's. And I think it's a better habit to get into. Right? When it says find dy dx, that means that y is your dependent variable and x is your independent. Okay, let's try number 2. Now, 2x to the 6th, y to the 9th. What is that? It's a product. So I'm going to have to use the product rule. Personally, I would group the 2x to the 6th together and the y to the 9th. So the derivative of the first factor is 12x to the 5th, and then times y to the 9th, plus 2x to the 6th times 9y to the 8th dy dx. Good. Okay, so I just did the derivative of the first one times the second plus the first times the derivative of the second, and when I took the derivative involving y, I had to stick in my dy dx. All right. Only if this had been a plus sign between the 2x to the 6th and the 9y with the dy dx. It's all multiplied together. Like if you have 2 times 3 times 4, that's 24. You don't multiply the 2 times the 4 and the 3 times the 4. It's just all multiplied together. So no, you can't really think about it as distributing it. All right, so what would the next term be? 3. And minus 3y squared dy dx equals 0. I wrote that as 52 cubed to kind of make sure you're really paying attention. Just because you see an exponent, don't write that as 3 times 52 to the 2nd power. 52 cubed is a number, and the derivative of a number is 0. Not always, but a lot of times it will. Okay, so the next step is to get everything with a dy dx on one side and everything else on the other side. And I'm going to factor the dy dx out. So if you can do that in one step, I'm cool with that. So I'm going to keep everything with the dy dx over on the left. And when I factor it out, I would like for 2x to the 6th, y to the 9th. I would really like for you to write that as 18x to the 6th. No, sorry, 2x to the 6th times 9y to the 8th. 18x to the 6th, y to the 8th. Minus 3y squared.
Y to the 8th.
Thank you. All right, and then I need to move the negative 12x to the 5th, y to the 9th, minus 3 over to the right. And then I can just divide. Is everybody okay on that second step? Did I lose anybody? Riley? If you'd like to divide that 3 out of everything in that, you're welcome to. If it's a free response question, then you're welcome to leave it the way I have it up here. If it's a multiple choice question, they may have factored a 3 out and divided the top and the bottom by 3. So that's it's just something to look for on a multiple choice question.